Hi everyone, my name is Marcos, and in this video we will show you our tool to combine machine learning models using a software product line approach. This work is published in the proceedings of the Software Product Line Conference 2024, and we are happy to announce that it won the Best Demonstrations and Tools paper. So the problem we try to solve with the software product line approach is the combination of two or more machine learning models. This way we try to embed the knowledge of all of them into a single one, and to do this there are several approaches and techniques. So just to illustrate very quickly these kind of approaches, we divide them into two main types. The first is model merging, where basically following a specific methodology we combine the weights of the parameters in a machine learning model, or even combining several layers, we can come up with a brand new model. In this example, on the left side, we are adding the weight of two pre-trained models, which can be seen as vectors, and when we add these vectors, we came up with a new one that should embed the knowledge or the semantics of the two original models. On the other side, there is another kind of methodology, which is called mixture of experts. In this methodology, we basically combine several machine learning models that we call experts in this specific problem. And basically each of them is an expert in a specific domain. And when combining all of them with a gated network that is in charge of redirecting the given input to the appropriate experts, we achieve a better model with knowledge in several domains. So now the problem itself we try to solve is the modeling of this process, of the combination of machine learning models. There are some tools out there that can do this job, but here our solution tries to model this problem in order to abstract from the underlying technology. And our solution, as we said, is software product line based. It is a no-code tool for the combination of large language models. We focused on this kind of machine learning models, although this can be extrapolated to any other kind of machine learning models. The tool comes with a feature model previously created, and then with a code generation stage, which takes the feature configuration we create from the feature model, and then generates the appropriate code, which is the LLM. In this diagram, we illustrate the overview of the tool, where basically there are two differentiated stages. The first one is the modeling stage, where the user interacts with the feature model, creating its own configuration. And then there are some evaluators that verify that the feature configuration is valid. And once this is done and the user is ready to create the model, it goes to the generation stage, where one of the generators is selected. It uses Hugging Face as a main repository to import the LLMs, then they are combined in the platform, and finally the resulting LLM is ready to be used and also to be published again in Hugging Face, so it can be reused again for the community, but also for further configuration. This is the features model diagram. For full details, it is everything explained in the paper, but the main idea is that here we can select the desired properties for our LLM, for our combined LLM. As you can see, on the left side, we can choose between mixture of experts or merge, and then each of the branches allows you to select the desired properties. Then this feature model allows you to select the specific tool for the LLM combination. And right now we only implemented one generator, which is based on MergeKit, and it's a very nice tool to combine LLMs. But here the idea is that when new tools are released, they can be simply added here. We can implement a code generator for them, and we can reuse the same feature model configurations. So basically the benefits this approach brings us are the definition of properties, requirements, commonalities, and variabilities in the system family of machine learning models. And also it allows us to generate a specific code for specific configurations. This way we abstract from the underlying technology, and we benefit from reusability and also maintainability of the products, which in this case are the LLMs. So now let's go with a live demo of the tool, where we will go through the process of creating a feature configuration from the feature model, and then generating the combined LLM. This is the graphical user interface of the tool, and on the left side we can see and modify the feature model. In this way we create the feature configuration that we will see on the right side. For instance, here we will create a mixture of experts from two specific LLMs. So as you can see, some of the features are blocked because they are mandatory, so this cannot be modified. But here we can choose between mixture of experts or merge, In this case, we will select mixture of experts. And then here we can select the cardinality of the expert feature. So we could add 2 or more experts here. We will set it to 2. And then on the right side, we will specify the attributes of this feature. As you can see, since we selected 2 experts on the right side, on the configuration side, we can see 2 experts where we will set the model name, which is the path assigned in Hugging Face, and some other features. A very important feature is the positive prompts that will trigger the activation of this expert for specific inputs. So inputs following a similar content as the ones in the positive prompts will assign higher probabilities for these experts to be responsible to generate the answers. In this example, we will select 2 specific LLMs specifically designed for chatting and for coding. And this way, we will come up with a single LLM which will be able to chat and also to generate code. So first, we will specify the model names and then the positive prompts. Okay, so we have the model paths, and now we need to specify the positive prompts. Here we can be creative, but we will go simple now and just write something like chat. And if we want to add more prompts, we need to specify the cardinality here on the feature model configuration. Let's put it to 2 positive prompts for the chat model. And then we do the same with the coding LLM. Here we can say we want 3 positive prompts. There is another feature for experts, which are the negative prompts, which is optional and allows us to specify prompts that should reject the activation of these experts. But in this case, we will keep it simple. And finally, for the mixture of experts, we need to specify a base model. And in this case, we selected one of the best ones in the leaderboards currently, which is this one. So now we have our feature configuration ready to be used to generate the LLM. Before doing it, we need to specify a name for the model. Also the output directory for the generated LLM, and then some properties regarding the upload for Hugging Face. If we want to publish it, we need to specify our username and our token of Hugging Face, and also the license under which we want to publish the model. Everything is ready. We can click on the Generate LLM button. And the generator creates the specific configuration for MergeKit, which is the specific generator we selected. And then the process starts. This is not a very long process, but of course it will depend on the hardware being used and also on the specific merging technique and the LLMs themselves. In this case, they are quite small. They are just 7 billion parameters. And this process can be run entirely on CPU, but it can also be accelerated with the GPU. So while the model is being updated to Hugging Face, we can quickly go through the source code of the feature model so you can better understand how it is implemented. For this tool, we designed our own domain-specific language, but the idea in the future is to refactor it to a standard language for feature models, which is UVL. But here you can have an idea of how the source code looks. This code, of course, can be modified, it can be updated to add new tools for LLM combinations. So the LLM has been generated and successfully updated to Hugging Face. Here we can see the generated weights, which are these .shape tensors files. And this has been also published in Hugging Face. As you can see, the model card has been automatically created. There are some details about the original LLMs used for the combination, and also a very simple tutorial to load and use the LLM. We hope you find this tool interesting. Don't forget to follow us on GitHub and LinkedIn, and feel free to contact us if you have any other questions or would like to use the tool. Thank you so much.